we ended with the discussion on uplink channels. So we have port channels and we have individual uplinks. Now, when I enable an uplink in the UCS FI, so I configure an uplink, that uplink is going to allow all VLANs automatically. So I'm going to automatically enable all of the VLANs on each of the interfaces. So that's a thing that you really need to pay attention to. By default, every time I configure, so there is, if you look at the CLI, if you do a show run interface Ethernet 1/8, I do that. When I do that, I will see a switch port trunk allowed VLAN list. Again, I cannot configure that manually. I need to do that in the manager or in any kind of other configuration style that the UCS supports. But I will see a switch port trunk allowed VLAN list. That VLAN will allow all the VLANs 10, 11, 300, 2001. But that list will be updated every time that I create a VLAN. Now in the software version that we're running in the lab, the 2.0, we can separate this because I might have a topology that says, all right, I have two uplink switches going down to one fabric interconnect. So I have switch 1 and I have switch 3. This one has one link and this one has two links in a port channel. They can tell you, make sure that VLAN 100 uses the switch 1 uplink. That is not a port pinning basis. Remember, port pinning is based on a server connection. So every time I pin a port from a client port to an uplink port, I pin all the traffic from my server towards the uplink. That single connection going down to my blade pins to a single uplink. So in this type of question, it says ensure that the VLAN 100 traffic uses the switch 1 uplink. So now I need to segment it based on VLANs. It doesn't change anything about the port pinning and how we solve that going towards the blade. I will talk about that in a couple minutes. So assume that we can have multiple connections coming from a single blade and every connection pins to a single uplink. So that single pinning blade to uplink, that stays. No change in that. But what does change is that I have multiple connections to blades. Multiple network interface cards. But we'll talk about that in a few minutes. What I first want to talk about is how do I segment that based on the uplink port. Because I said every time I enable an uplink, which is just a single setting, configure as an uplink port, from that moment on I allow all the VLANs. This feature that they introduced in UCS 2.0 is called Disjoint Layer 2. And that's a very fancy word for just saying to adapt my switch port trunk allowed VLAN list. That's all it does. But it does one other thing. So Disjoint Layer 2, if you see that on the roadmap, which is a roadmap or a blueprint item, sorry, not roadmap, a blueprint item for the data center test, you will see Disjoint Layer 2. What you will be configuring is this. You will be configuring mappings for, let's say, uplink interface to a VLAN. I create this mapping. This is done in what's called the VLAN manager, which I will show you after the next break. I will show you in the demonstration. I will show you how do I map from an uplink to a VLAN in the VLAN manager. And I create this a one-to-many mappings. So many-to-many mappings actually. I can map one uplink to multiple VLANs. I can map a single VLAN to multiple uplinks. So I can allow, in this case, if I would have two links that are not port channeled to switch 1, I would allow VLAN 100 to go on these two connections, right? So on a normal switch, on this switch configuration, I would say switch port trunk allowed VLAN 100. And here on switch 3, I would say switch port trunk allowed VLAN 300 on these two ports and on this port. So here I would enable 100, and here I'm enabling, let's say, 300. Don't care much about the numbering. But I can have multiple, so one VLAN can map to multiple uplinks. And one uplink can map multiple VLANs. That's many-to-many mappings. So that's the first step that I do. What does this mapping do? If I do that, I click on an uplink, I click on a VLAN and I say apply. What it does is it will change the allowed VLAN list. What would you expect? I select a VLAN, I select an uplink, I select a VLAN. What I would expect with my networking background is that this would say, let's say this is port 8 and I allow VLAN 100. So I select port 8 to VLAN 100. What I expect this will do is switch port trunk, allowed VLAN 100. It doesn't do that. What it does, so this is not the case. What it does a switch port trunk allowed VLAN remove 100 on all the other links. All the other, what it does is if I map this, so port 8 to VLAN 100, what it does is remove VLAN 100 on all the other ports. So going back to our drawing, 8 to 100, it will say, all right, port 9, port 10, and port 11, or port channel 1, sorry for that, port channel 1. Switch port trunk allowed VLAN remove 100, remove 100. And now VLAN 100 is only allowed on port 8. Now, okay, that could be a situation, right? But that's not what I want, because I also configured VLAN 300. So on port 8, what is my allowed VLAN list right now? It will show 100 and 300, because I did not remove VLAN 300 from port 8 yet. So if all I do is 8 to 100 and then 9 to 100 to finish it, right, to get this configuration done, it will forward VLAN 100 traffic out of these ports. That's cool. The problem here is not VLAN 100, it's VLAN 300. VLAN 300 is still allowed on all the ports, because all it did was removing 100 from all the other. So I also need to map VLAN 300 to port channel 1. What it will do then, if I map 300 to port channel 1, it will now do a remove command on ports 8 and 9. So very distinct difference, and here is where the CLI is very useful. Because if I do that show run interface, I can see that trunk allowed list, and now I can trust with my networking background, I trust myself for, let's say, hey, all right, that's what it's doing, right? The GUI is fake, but the CLI I trust. Also, from other things, UCS 2.0 is not considered, or actually 2.05 is pretty stable, but the 2.02 had some issues in the GUI where sometimes things that are really happening on the CLI did not show up in the GUI. So 2.05 is pretty much okay, but to be sure if something's not working, check the CLI for networking parts. On server ports, that's more difficult because the CLI is limited, but on the networking part, I have NXOS available. So I can do all my verification that I'm used to of doing on Nexuses. So again, to remember, it doesn't say switch port trunk allowed VLAN. The only thing that the VLAN manager is doing is removing things from other links. That's what the mappings do. And that changes all over again in UCS 2.1. And that's what we're going to talk about next week. So remember this for now and forget about it next week. That's pretty much the message here. So that's Disjoint Layer 2. The other feature, why they do not call it VLAN grouping or VLAN managing, they call it Disjoint Layer 2 because of the broadcast traffic. Like I said, I pin links to uplinks, server links to uplinks. That's a one-to-one mapping. If I did that mapping, now what if a broadcast packet came in from VLAN 100 or going towards VLAN 100? Where does it need to go out? I cannot pin that, right? It's not coming from a server link, it's coming from an uplink, but it needs to go out on all my ports. So what the Fabric Interconnect does is for broadcast and multicast traffic, which is the same on the layer 2 basis, for broadcast and multicast traffic, what I do is I do not want to flood it out on all my uplinks, because again, if I flood it out on all my uplinks, I might end up in a loop. I flood the network, and that's not what the switch is expecting. This switch expects a single host connected to its links. So it does not expect the same packet on multiple links. So also for broadcast traffic coming from a server, so every ARP request, for example, here in VLAN 100, every ARP is only being forwarded out one uplink. But I'm not using the pinned uplink for that. I'm using what they call the designated receiver. The designated receiver is the broadcast and multicast port for any given VLAN. And that's per VLAN. So what I do is I select a single designated receiver, which is a physical uplink port. So in this case, it might be port 8. I select that port and I'm going to say, all right, every time I receive a broadcast packet or a multicast packet in VLAN 100, I'm going to use port 8 as my exit port. And that is a selection done per VLAN. And because I now have that disjoint layer, this designated receiver, that's new in UCS 2.0, was new in 2.0. So that port is now a per VLAN port, and so every VLAN selects its own designated receiver, and it also, of course, load balances for that. So not a single port in the system carries all the broadcast traffic. That was actually the case in UCS 1.0 or 1.x. So designated receivers is the other part that the disjoint layer 2 does. It segments everything per VLAN. So very useful. So that's my disjoint layer 2. That was my networking part. About one thing, we talked about static pinning, right? We talked about the pinning that servers do to a single uplink. So I select only one port for all of my broadcast traffic. So let's say here I have two different uplinks going to a switch. I will select only one to carry the broadcast traffic, because I never want to send two packets, because technically if I'm a switch, I need to flood it out on all my links. But now I'm only selecting it once. So it's not, so yes, it happens for blade to uplink traffic, but the reason I do it is because when I have multiple, I need to select one. So even when the traffic is pinned like this, so let's say blade 2 sends a broadcast packet, and this link, this green link is chosen to be the designated receiver, the broadcast packet from blade 2 will be traveled across that single link. So that's the designated receiver. And yes, it's chosen automatically. You cannot even change it. It's chosen automatically and it's there. So it chooses one of the possible uplinks, and possible uplink means the one that has the VLAN allowed using the disjoint layer 2 configuration. All right, so one more topic in this case for the pinning and the learning and the designated receiver stuff. One more topic about that, and that is pin groups. So the last topic here is pin groups. Like I said, or like we discussed, I have my switch, I have a fabric interconnect, and I have my two blades. Both decide to use any given uplink. Going out left and right. So what I do here, let's say I have a preference to say blades 1, 2, and 3, I really want you guys, or the NICs on blade 1, 2, and 3, so I can make that per network interface card, that selection. Per network interface card, I can say, all right, this network interface card is using this specific uplink. So that's a very important difference. So, like I said, each blade can have multiple network interface cards, not physical but virtual ones, but we'll talk about that in a minute. all these cards select a single uplink automatically, and it's static. So once it's made, I cannot change it. What I can do is I can influence the decision. So what I can do here is I can adapt certain changes. So I can influence the pinning. What a pin group does, and I can do that for fiber channel and for Ethernet ports. So what I do here is, as I say, all right, this network interface card or VNIC will use this uplink. Always. Of course, this uplink is still subject to all the rules that it has to apply for it. So it still needs to allow all the VLANs, for example. It needs to be in the up state. Every time, if it complies to these requirements successfully, so all the VLANs that this NIC wants are allowed on this uplink, the uplink is up, then I will pin it to that uplink, and I will not do that automatically. I do not care about how many other links are already pinned to it. I will always add it to that list. So this VNIC to uplink mapping, I can influence that by using pin groups. I can say, all right, if it runs on Fabric A, it needs to select this. If it runs on FIB, it needs to select this. So there's some flexibility there. So I do not see a lot of use cases for this, because usually if traffic already enters A or B, it already chose an uplink, and then it can just use any as long as the VLAN is allowed. So very important, disjoint layer 2 and pin groups have nothing to do with each other. I cannot influence VLAN 100 traffic should go out port 9. No, what I say here is network interface card X uses uplink